That would be great, yeah.
Because like I have 5 tests on Monday, so on Tuesday I do make like one test.
Okay, yeah, let's do that. Like 6th period would be better.
Yeah.
Studying all Thursday. Yeah, that'll be good. Just remind me. Okay, so compression. Let me extend this here. If I go back to A, if A is a number, and actually I'm going to put absolute value, because if A is negative, we're going to ignore the negative. So if A is between 0 and 1, ignoring the negative sign, it's called a compression, or sometimes we call that a shrink. I don't mind if you use shrink or compression. If the absolute value of A is bigger than 1, it's called a stretch. The K value. The K value is the up and down, and it does exactly what you think. So I know I've been doing it almost like a cheer, but we've done this with absolute values, with parabolas, with all the polynomials. We go left, right, up, down, stretch it, shrink it, flip it. Woo! Okay? So it's the exact same thing with exponentials. So that's great news. You're not really learning something new except a new shape. Okay? So, looking at the next slide, it says the dashed figure is the image. That means the end, where it went. Pre-image is the original. So the original is solid. The image is the dashed. So what I want you to do, I'm going to give you a head start. And I want you to look at 1, 2, and 3. And I want you to tell me, is it a translation? Translation's a slide, left or right, up or down. Reflection is, did it get flipped upside down? Or dilation, if you remember from geometry, a dilation is a stretch or a shrink. So all I want you to do, and let me kind of write that down. A translation is a slide. So that's left, right, up, down. Okay? Translation is a slide. Left, right, up, down. Reflection is a flip. And a dilation is a stretch or shrink. So maybe jot that down first so that you are aware of what they are. Then go back above and next to 1, 2, and 3, put which word? Translation, reflection, dilation. And you should have one of each. Hint, hint. Okay?
I know it's a little off topic, but how do you know if there was a wheel along?
That happens simultaneously?
Yeah, something happened.
That's a great question. It would continue to go. It wouldn't stop. That's how you know. All right, number 1, CJ, what do you think this one is?
Reflection.
Nope, a reflection would make it go upside down. Jacob?
Translation.
It's a translation. It has been slid, and here's how I figure it out. I look at my y-intercept. Where did it go? It went right 2 units. Okay? All right, Emma, how about number 2? What do you think happened here?
A dilation.
A dilation. Do you see it's wider? Okay, it's wider than the original. And then, Kat, what do you think about number 3? It's a reflection because this one's been flipped upside down. Okay, it's been flipped. All right, when you're ready, flip the page. Honey. All right, I had chocolate at lunch. So ready to go. So the function f of x is negative 0.5 times 5 to the x. And the parent function is graphed below. So what is the parent function? Does anybody know what it is? I didn't give it to you.
Oh.
No, I mean, what's the equation? No, that's this one. Negative 0.5 to the 5x. But what would the original have been? What would be the equation? Like, what was the starting equation? Okay, so it's actually this. Before you do anything, it's the b to the x. Okay, it'll always be the b to the x. Well, our b in this one is 5. So you're right, the original is the solid, and then the negative 0.5 times 5 to the x, guess what happened? It flipped it, so we're going to call it a reflection. And what does the 0.5 do? That's a stretch or a shrink? It's a shrink. Now, let's do the domain and range of the transformation. Domain of all exponential functions are negative infinity to infinity. The reason why is because my graph goes left forever and right forever. Okay, the x's are the left-right. My range are the y's, they're the up-down. So now I'm talking about the transformation. This one going here. What's the range? Okay, it's 0 down to negative infinity, but that's actually not the way we can put it in interval notation. How do we say it in interval notation? It doesn't start at 0 then, even though it is 0 down. How do you write it? So the first one is the smaller one, so it's negative infinity to 0. The y-intercept. You guys remember the y-intercept is 0, comma, the a value. Now, there was one more thing I wanted us to add that I forgot to put a blank. There is a horizontal asymptote of y equals 0. All right, when you're ready, look at the next slide, and I want you to try as much of this as you can do. It says f of x equals 4 to the x. So that's the parent function. Then I said the transformed or changed function is g of x is 4 to the x plus 2. Describe the transformation. How is it going to get moved? And then I'm going to show you how you do this. It's not that bad. All right, so Alyssa, based on this equation, 4 to the x plus 2, how has that one shifted then? Nope, I don't have a number in front. Katie? It's left 2, okay? The only thing that changed was the exponent. So let's go back to my first slide. Okay, if you remember, up in the exponent is the left-right. Okay, that's your left-right, and it does the opposite of what you think. So that's left 2. Okay, now watch this, okay? I'm going to change color so you can see it on mine better this way. But look, do you see I currently have a y-intercept of 0, 1? You see that? If I want to shift it left 2, you literally count. 1, 2. There it is. Let's get one more point. Do you see at 1, 4? Okay, that's 1, 4, and I could check it algebraically. I could plug in x is 1, 4 to the 1 is 4. Now watch, I'm just going to count. 1, 2, 2 to the left. Then I know all exponential graphs are going to hug the asymptote. So the only time the horizontal asymptote will change is if I shift up or down. So my domain is negative infinity to infinity, and my range is 0 to infinity. Let's go ahead and put the horizontal asymptote on. And just because I've taught Algebra 2 a very long time, something common that I see students forget is drawing the dashed horizontal asymptote. If you're asked to make a graph, it has to include the horizontal asymptote. It's kind of the boundary line. And we just did C, okay? We just did C.
Will we ever have a vertical asymptote?
Great question. Yes, we're going to see that in 7.3. Do you remember how we talked in chapter 6 about inverse functions?
Yeah.
So like if you add, the inverse is subtract. If you multiply, the inverse is division. If I square, the inverse is square root. Well, exponential functions have an inverse called a logarithm. So then our logarithms we're going to learn about have vertical asymptotes because you're switching, okay? So that's really kind of cool. All right, now flip the page when you're ready. And it says the dashed function shows the transformation. What transformations are occurring in each graph? This time, I don't want you to say translation, dilation, reflection. I want you to say something like right 2, down 1, stretch of 3, okay? See how many you can do. I guess on your one that's a shrink or a stretch, you can't tell. It doesn't. I don't think you can. Well, maybe you can figure it out. I don't know. All right, when you're ready, check mine. So letter A is up 1, and you can tell that from the y-intercept. It didn't get skinnier, okay? It didn't get skinnier. It is the same shape. Letter B is a reflection. It's definitely upside down. Letter C, it is the same shape, okay? All I've done is I've moved that y-intercept, that point, right 2. Now, letter D is definitely, do you see it's a lot lower? So it's a shrink. Yeah.
So if it's lower, it's a shrink, and if it's higher, it's a stretch.
Uh-huh. Yeah, it's a great question. So like if it had gone from here and it went like this, like super skinnier, do you see the difference here? This one is the same shape, but it's just been moved up. So it has to be that it's definitely a different shape. Yeah. All right, last slide for this first part is we talked yesterday about compounding interest, and I gave you an orange half sheet with several formulas. What we're going to do today is we're going to learn about a new one, and it's called PERT. Whoops. There it is. Okay. And I like to call this one PERT. It's A equals P times e to the RT. You're going to use this one only when you see continuously compounding. So here's the big idea. Can you guys find that orange formula sheet for me? Because I want to differentiate what you do here. It says, suppose you deposited your earnings into an account at the beginning of freshman year that pays 5% annual interest compounded continuously. So I want you to circle those two words and then look at the orange half sheet. It says compound interest and continuous compound interest. You will use compound interest all the time except when it says continuous compounding, okay? So this one is continuous compounding. it says you start college 4 years later and spend 4 years in college. About how much will be in the account when you graduate from college? So, do you see on your paper, doesn't it say 5,000? Okay, I'm like, I can't see it on here. So I have $5,000. I do R is 0.05, and it's not 4 years. You do 4 years of high school, 4 years of college, so that's 8. So take out a calculator. Okay, take out a calculator. And let's make sure you know where the E button is. On a red calculator, let me pull one out to describe where the button is. You should be able to see it. I believe it's on the left column on the graphing calculator. And it's on the left column on the red ones. Do you see below the yellow second button on the red ones? There's a button that has an LN. In yellow is E to the X. Okay? The same thing I think is true on the graphing calculator. On the left column, you see your E. Yeah, it's underneath the caret button. So you're going to do 5,000, hit your E button. On the red calculators, you have to put a parenthesis around it. On the graphing calculators, you don't. So this is E to the 0.05 times 8. So this is $7,459.12.